Conservative and non-conservative forces. When we talk about force, the first thing that comes to our mind is a push or a pull, something that changes the position of the body, something that can change the configuration of a body or a system of bodies. These are all forces that we encounter, and these are what we have been studying in our course so far. Now, the force can be mechanical, it could be electrical or magnetic. So, what are we going to study? We want to look at a force which we can term as conservative and another type which we are going to term as non-conservative. We will define parameters on the basis of which we are able to categorize force under conservative and non-conservative category. A conservative force is a force if the work done by or against the force in moving a body depends only on the initial and final positions of the body and not on the path followed between the initial and final positions. In the activity that we had done, the man came down from a height and took 3 different ways to go down. He went down the stairs, he went following a separate path. In all these cases, the change in its height remained the same. So, height from top to the base, which was 0 potential energy. So, the initial position and the final position were to be determining the change in his potential energy. So, this kind of force where it does not depend upon the track you take is going to be termed as conservative. One thing we must remember, that the man must have taken a path, he must have travelled on that track, and while travelling on that track, he must have lost some energy against the frictional force. So, we cannot say that if he was to jump from here to here, it would be the same work done as it would be when he went down the stairs, took a path around the house or went through the house. So, in all these cases, you are also picturizing the effort done by friction in order to oppose what this man wanted to do in changing his position from here to the ground level. The same thing happened when we were doing the activity with the cars. On a rough surface, there was more friction, so there would be loss of energy. Likewise, when this bumpy road was there, you saw that the car moved differently. So, it is on account of this we are going to talk about conservative and non-conservative force. The conservative force therefore would mean if there were objects placed at a particular height and all of them jumped down. Even then we have to take care of the air resistance. If it was happening in vacuum, then yes, that would be perfect conservative force idea. But other than that, there is always going to be non-conservative force. Let us take a closer look. Over here we have this building and a rough surface and a bumpy surface, 2 vehicles, a man sleeping up here. And how are we going to connect conservative and non-conservative forces? Supposing this car was to go on this rough surface. It stops here, I can give it a larger force and it stops after some time. Now, if this person decides to go down to the cars, he has several options. He could take the stairs which are at the back of the house, which are inside the house, or he could climb onto the parapet and jump down from here. In each of the cases, he travels different distances. For example, if he was to go down and take the back stairs to go, he would go down and then travel all this distance to reach the car. He could have another option, in which case from his position up here, he could go down to the inside stairs and through the house come out in this location, or he could go on to the parapet and jump from this position to the ground. In all the three cases, the distance he has moved is different. But what is the change in his energy? How much is the change in the energy of the cars? That is determined by conservative or non-conservative forces. Some work is done in raising a body against gravity. So, gravity becomes one of the most important conservative forces. That is the example which is given in all the books. But as we had just discussed just now, this change in position, though changed the position in terms of the height of the man with respect to the ground, the track that he took was also important. However, if we just take, say, an object and take it up in different tracks like this and ignore air resistance, then this track is not important, but only the height that is from here to here. This is the picture that is given in the books. So, you have to see a real life picture of conservative force and what you have in the book. So, both of them, one is an ideal situation as we have been talking about, and the other is the real picture. The other kind of conservative force that you have learned is the elastic force for stretching a spring. So, that is also conservative if there is no loss of energy. Within elastic limit, most of the springs show this property of working with conservative forces. So, the energy which is stored in it every time you compress or elongate the spring is remaining the same. But we all know from our use of springs in daily life that after some time that spring becomes what we term as loose, and therefore, it may not be following the conservative force law at that point, but we take it in general as a conservative force. Are there other examples of conservative forces? Electrostatic force is a conservative force. What is this force and where does it act, and do we see it in our life or do we experience any of it in our life? Yes, we do. The electrostatic force occurs between stationary charges and it is capable of storing in energy. Supposing you have learned before that positive charges, like charges, repel. So, supposing there were two positive charges, there is a positive charge and here is another one. If I am trying to bring it closer, I would be bringing it against their wish, or I would be trying to store energy. If it is allowed to move away, it will move to a point where the potential energy becomes the least. So, this is also a kind of conservative force that you will encounter. Magnetic forces between magnets also can be conservative forces, but they are conditional. We define central force. A central force is one which acts between objects in such a way that you can take into consideration the line joining their centers. That is to say, if I were to talk about a central force between these two, I would talk about the center of gravity of this car and this one, and therefore talk of it as a central force. That is the meaning of central force. Conservative forces are central forces. Gravitational force, which we have been dealing with in our mechanical energy consideration, is a conservative force and is also a central force. So, let us enlist the properties of conservative forces. Work done by or against a conservative force depends only on the initial and final positions of the body. That is to say, if a man jumped from here to here, then the initial and the final position is responsible to talk about it. Then we will say that the work was done under conservative force. If the same man took this stairway, went around the house and came out here, then you would be saying that some non-conservative force was also involved, because the longer the route he takes, he would have lost some more energy. So when things are dropped or are falling from a height, you are under conservative force because you're choosing to ignore air resistance or the viscous drag which is created by the air or the wind. So work done by or against a conservative force does not depend upon the nature of the path between the initial and final positions of the body. Nature of the path means whether the path is rough, whether the path is bumpy, whether the path provides more friction. All these things, if you take care of, say that there is nothing like friction, there is nothing like a rough surface, there is no loss of energy, well, then the same man could have gone anywhere by any means in any direction and would have reached the ground by losing the same amount of potential energy. And we would have said that he was under conservative force. Work done by or against a conservative force in a round trip is zero. The concept of potential energy exists only in the case of conservative forces. The work done by a conservative force is completely recoverable. What is the meaning of that? All the calculations that we have been doing for transferring of energy from potential to kinetic or kinetic to potential are based on this fact that there is no loss of energy. There is no way that there is any other force acting on that object. That means we are choosing to ignore air resistance. A body thrown up, the body comes back to the person's hand. You say the way you threw the ball, the kinetic energy you gave it, that is responsible to the height it will gain. If you throw it with a higher velocity, it will rise higher and it will come back and you will catch it with the same speed as you had thrown it up. Now this particular assumption comes from the fact that there is no other force acting other than the gravitational pull. So air resistance on the way for the ball to go right up and come down is ignored. Non-conservative forces. A force is said to be non-conservative if the work done by or against the force in moving a body depends upon the path between the initial and final positions. Let us describe what is responsible for forces to become non-conservative. Frictional force is one of them. So frictional forces are non-conservative. The work done against friction depends on the length of the path along which the body has moved. So if this car was moving on a rough surface, then the frictional force was responsible for how long it would move on it. Supposing I force it to move on it, then more frictional force would have acted on the car. The path length is therefore important. Work done by frictional force in a round trip is not zero. Analyze it and think about it, what would happen? The wear and tear of the shoe sole, the wear and tear of the car tire, the heat that is generated, all this is responsible to tell us that the frictional force in a round trip has lost some energy, and therefore you cannot have the work done equal to zero if you are making a round trip. And by round trip we mean that starting from an initial point, traveling a lot of distance and coming back to the same initial point. So the final and the initial positions must coincide if you are talking about a round trip. And in frictional forces, you are never going to have zero value, as we had explained in terms of conservative forces, where you would get the zero value. Do any of the forces depend upon the velocity? Would a conservative force depend upon the velocity with which things are moving? In the case of non-conservative forces, do you think velocity would take care of some of the losses? Air resistance, viscous drag and magnetic forces are non-conservative and are velocity dependent. Let us put all this that we have learned about conservative and non-conservative forces as a comparative chart. Of course, we now do understand that there is nothing like a conservative force. You have to imagine it bereft of any other thing that could take away the energy of the body when it is being acted upon by a conservative force. And only then in an ideal situation do you talk of an conservative force. So here's a comparison of the two. Conservative force and non-conservative force. Work done in conservative forces does not depend upon the path length. On the other hand, for non-conservative forces, work done depends on the path length. For conservative forces, work done in a round trip is 0. For non-conservative forces, work done in a round trip is not equal to 0. Conservative forces are central in nature. Non-conservative forces are not central. Conservative forces are velocity independent, but non-conservative forces are dependent on velocity. In the case of conservative forces, the total mechanical energy is conserved at all points and at all times during the motion from initial to a final position. In non-conservative forces, energy is lost, maybe as sound, as heat. Work done by conservative forces is recoverable. Non-conservative forces, the work done is not recoverable. Since so many forces take charge of our lives in terms of what we want to do and how we want to perform certain things in our daily life, we come across non-conservative forces and we have to take care of that. So nothing can be 100% efficient where you say the work done on something is going to give us the work done by it. That means the output of machines, the output of whatever we do is never going to be the input that we put in it. So I hope you have understood what are conservative and what are non-conservative forces.